Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. We all know that earthquakes are one of the most dangerous disasters in the world. So an instrument is needed to measure earthquakes to minimize the impact of such events. The instrument is seismometer. Before we explain you about seismometer, I want to introduce ourselves. In here we have Prima Panggalo Linggi, Zahra Luma, Fahri Kuncoro, and then Alvin Martinus. Number one is, what is seismometer? In the beginning, we want to explain you about the different seismograph, seismogram, and then seismometer. Seismograph is an instrument used to record seismic wave. Seismogram is a graphical record produced by seismograph. The data result from the ground motion such as earthquake. In the recording, there is a graph of P wave, which comes first, and then S wave. In here we have seismometer. For the seismometer digital already can measure the north, south, east, west or horizontal wave and then vertical wave. In the illustration we have vertical and horizontal. Basically the both are similar, have spring, pivot, mesh and coil. The difference is in the placement. For example, in the seismometer vertical, the sensor body in here. For read the wave vertical move left and right. Seismic instruments have the main two sensor types. Our seismometer are very sensitive to small and distant events, and then accelerometer too sensitive for strong motion. For weak motion sensor or seismometer are divided into two categories. Number one is the short period seismometer, frequency 0.1 Hz until 1 Hz, and then the broadband sensor seismometer 0.01 to 50 Hz. In the illustration are example of short period and broadband type brand like Group 3T, Group 40T, and Nanometric Trillium 240 for broadband brand.
Next up is the component of seismometer. Now this image shows the internal and external structure of a seismometer, which is an instrument used to detect and record ground motion during seismic events like earthquakes. Now I will explain some of the label components. Now on the left side we have the internal components. On the top there's digitizer. It converts the analog signals from the sensor into digital data for processing and recording. Ensures that seismic data can be transmitted and analyzed electronically. Then on the left we have tilt meter. Measures the tilt or inclination of the instrument to motion changes in the angle of ground. Then there's interface or junction layer. It serves as a connection point for electrical components, enabling communication between sensors and digitizer or external systems. Up next, there's seismometer electronics layer. It houses the electronic circuitry required for signal amplification, filtering, and initial processing of raw seismic data. Next, there's vertical sensors. It detects vertical ground motion caused by seismic wave, complements the horizontal sensor to provide a complete 3D picture of seismic activity. Then there's horizontal sensors, measure horizontal ground motion into perpendicular direction to capture the full range of seismic wave. Then there's bendix. It refers to a connector or joint that facilitates electrical or mechanical connection between different components of the seismometer. On the right, there's the fuse. Protects the sensitive electronics by preventing damage from electrical overloads or surges. Then there's the titanium base. It provides a sturdy, corrosion-resistant foundation for the seismometer, ensuring stability and durability in harsh environments. Now on the right side, we have the external view. The right side shows the outer casing of the seismometer. The cylindrical housing protects the internal components from environmental factors like moisture, temperature changes, and physical damage. Now the connector on top. It allows for power input and data output, enabling the device to communicate and monitoring systems.
Next is the how seismometer works. This diagram explains the working principle of two types of seismometers, instruments used to detect ground vibration caused by earthquakes. In a seismometer without feedback, the inertial force from ground vibration moves the inertial mass, resulting in large mechanical displacement. This displacement is detected by transducer, which converts it into a electrical signal. However, large displacements can cause nonlinearity, reducing measurement accuracy. In contrast, a force balance seismometer compensates the inertial force with a feedback force, keeping the mechanical displacement small and linear. The electronic system records the current required to balance this force and then converts it into an electrical signal. This approach enhances the accuracy and sensitivity of the seismometer.
Now I will explain the steps of how a seismometer works. First, sensor input. The sensor detects ground vibration and generates an analog signal representing the movement. Analog to digital converter. The analog signal from the sensor is converted into a digital signal so it can be processed by a computer. GPS. Used to record time with high precision, ensuring the vibration data has an accurate timestamp for analysis. Computer. Process the digital data retrieved from the ADC and manage communication, whether with either device or a data processing center. Data storage. Data storage. The processed data is stored in a storage system for further analysis or archiving. Power supply. Provides power to the entire system to ensure stable operation. And the last, communication. The data can be transmitted to a monitoring center or other user via a communication network for real-time or remote analysis.
We have seen how seismometers help us detect and study earthquakes, providing important information about Earth's movements. These instruments are not only useful for science but also for helping people save. Thank you for your attention. I hope this explanation has been helpful and easy to understand. Thank you.